Hi, welcome to this lesson on Probability Counting Principles Part 1. Let's have a look at factorial notation. So what is factorial notation? Let's have a look at this example. A photographer needs to take a picture of 5 people all standing next to each other. How many ways can the 5 people stand next to each other for the photo? So if you let A1 be the event of the first position in the line, then there are 5 people to choose from. So you can imagine this is the line for the people. So there are 5 people that can stand in the first position. So of those 5, one of them are chosen. Now we need a second position in line. So one person's already stood here. So there are 4 people left to choose from in the second position. Once you've chosen a person from the second position, there are now 3 people left to choose for the third position. So you choose someone to stand here, then there are 2 people left. Once you've chosen a person here, well, there's only 1 person left in that line. So, by the fundamental counting principle, there are 5 times 4 times 3 times 2 times 1 different ways that we can choose the people standing in that line. So that's this number here, which is 120. So we have a nice compact notation for when we multiply natural numbers in a consecutive order. So consecutive meaning that you're going down the list by 1, 5, 4, 3, 2, 1. Okay, and we're looking at natural numbers. So let n be a natural number, then we define what we write here as n factorial, so n with an exclamation mark. So no, n is not shouting at you, it's just saying n factorial, and that is defined as the number n times the number before it, n minus 1, times the number before that number, n minus 2, all the way up to until you get to 3, 2, 1. Okay, and then we also have a special definition. 0 factorial is equal to 1. And we'll see why we've defined it like that. So the exclamation point, like I said, is the notation that is read as n factorial, and is defined as the consecutive product of n numbers in that descending order. So for example, 3 factorial is 3 times 2 times 1, which is 6. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5040. Okay, so 5 factorial, for example, that would be 5 times 4 times 3 times 2 times 1, which is what we had just now. So that means the number of ways we can arrange those 5 people in a straight line is 5 factorial ways. So the factorial tells us how many ways we can arrange in objects. So by our definition, so if you're arranging n objects in a straight line, okay, how many ways can you do it? Then by definition, it makes sense to define 0 factorial as 1, as there's only one way to arrange 0 objects. That is just once, because there's nothing to arrange. Okay, so that's why we define 0 factorial as the number 1. Okay, so that is factorial notation. I'll see you in the next one.